Welcome to the mathematics class of Mr. Larry Whittington. Stay tuned as Mr. Whit get on here today and speak to us about fractions. I hope you figure to understand what he gonna teach. Get your ink pen and your pencil out, your calculator, and get ready to learn something from Mr. Whittington, Fort Bend Tutoring.
Hello ladies and gentlemen, this is Mr. Whit with Fort Bend Tutoring, and today's tutorial is going to be about rational functions and finding slant asymptotes. Yeah, oblique asymptotes. So first of all, when dealing with rational functions, you need to know that you'll be using the format f of x equals to p of x, a function divided by another function where this function in the denominator cannot equal to 0. It just can't. It would be undefined. So therefore, this is what you're looking at, that right there. Okay, that's a rational function. And now, let's talk about how to find these slant or oblique asymptotes. All right, here we go. There we go. Let me line that up for you. Line that up. Okay, there it is. How to find oblique asymptotes, aka slant asymptotes. It's the same thing. It's the same thing, people. Okay. Number one, if the degree in the numerator is 1 more than the degree in the denominator, then you're going to use long division in order to find the oblique asymptote. When doing the long division, you're going to ignore any remainders that you may end up with, and the linear quotient is your oblique asymptote. 2 steps. That's all you need to do. So let's go ahead and check out some examples. In problem 1, we have y equals 2x squared minus 7x plus 10 divided by x minus 2. Now notice how in the numerator we do have a quadratic trinomial, but in order to find the oblique asymptote, we do not need to factor this. Alright? In fact, you don't want it to be factored. And if it is already factored, you probably want to multiply together. It'll just make the process that much easier. So that being the case, in order to find the oblique asymptote, that slant asymptote, I want to use long division. I am noticing that in the numerator, the highest degree of any term is 2, all right? Whereas in the denominator, the highest degree on any term is 1. So notice that this term 2x squared has obviously a 2 on the variable x, and in the denominator, the exponent on the variable x is 1. So here I'm comparing in the numerator, the highest exponent on any variable is 2, whereas in the denominator, the highest exponent on any variable is 1. That difference between 2 and 1 is 1. And anytime the highest degree in the numerator is 1 more than the highest degree in the denominator, we can find the slant asymptote by using long division. I'll have x minus 2 going into 2x squared minus 7x plus 10. Alright, you want to make sure that each of your expressions here, whether it be the divisor or the dividend, you'll have each of those terms written in descending order of your variable, and you'll account for any missing terms. Alright, so if you need a refresher on dividing polynomials, go ahead and check out this video right here. Alright, so I'll begin by recognizing that the first term x needs to be multiplied by 2x in order to get the term 2x squared. So x goes into 2x squared 2x times. So then I'm going to distribute. 2x times x gives me 2x squared, and then 2x times negative 2 will give me negative 4x. From here, I'm going to be changing the signs. Change the signs. Alright, my 2x squares will cancel out. The negative 7x and the positive 4x will give me a negative 3x, and then I'll be bringing down that next term. It's positive 10. From here, I want to determine how many times I need to multiply x in order to get negative 3x. Well, I need to multiply by negative 3, right? So negative 3 times x is negative 3x, and negative 3 times negative 2 is positive 6. And from here, you would want to change the signs. So that becomes a positive, that becomes a negative, and I end up with positive 4 as a remainder. Remember, we'll be ignoring this remainder, and my slant asymptote is going to use that 2x minus 3. So we'll write it out as a linear equation. It will be y equals 2x minus 3. This is your slant asymptote. That's it. This is going to be the line that your rational function will get closer and closer to as it moves away from 0, but will never touch. This is the oblique asymptote. All right, let's put a red box around it. All right, and not only are we going to be identifying the slant asymptote, we're going to also graph it. So here I have my original function again, that y equals 2x squared minus 7x plus 10 divided by x minus 2. We found out that our oblique asymptote, that slant asymptote, is going to be y equals 2x minus 3. And now we're going to graph it. So using my slope-intercept form, I know that the slope of this line is going to be 2. I know that the y-intercept is negative 3. And I'll be using those pieces of information in order to graph my linear equation. So if you need a refresher on graphing linear equations using the slope-intercept form, check out this video right here. Okay? I got you covered. I got you covered. There you go. I'm looking out for you. So I'm going to always start with the y-intercept. That means I'll be placing a point at negative 3 on the y-axis. So I got my point right there at negative 3 on the y-axis. And then using the slope, which will be 2 over 1, if you write it as a ratio, I'm going to go up 2 from my y-intercept and then go over 1, and that'll give me a point right there. And now I'm going to graph it. And then when drawing your asymptotes, you always want to use a dashed line or a dotted line. So I like the dashed lines. All right, that's just what I like to roll with. There we go. This is the line that my rational function will avoid. And also keep a note that any rational function will have no more than one slant asymptote. So there'll never be a case where you'll have multiple slant asymptotes. All right, so there you go. There's the graph of your slant asymptote for problem number 1. Now we're on to problem number 2. In problem number 2, we have y equals x squared minus x divided by x plus 1. Now we could factor out an x in the numerator, but as I told you before, you don't really want to use the factored form. So we'll just keep it just like this. I am noticing that the highest degree in the numerator is 2, whereas the highest degree in the denominator is 1. So once again, we do have the situation where your highest degree in the numerator is 1 more than the highest degree in the denominator. All right, so that's perfect. We'll use long division in order to find our slant asymptote. So my divisor will be the denominator, which is going to be x plus 1, and the numerator will be my dividend. It'll be that x squared minus x. All right, from here, I need to multiply x how many times in order to get x squared? Exactly. You're so smart. I need an x. That's right, because x times x is x squared. You're awesome. Then multiplying x times 1, you get a positive x. You do. And I'll need to change the signs. Change them. So you'll end up with a negative here, that becomes a negative there, and my x squareds will cancel out, whereas this negative x and that negative x, remember I changed the sign, you'll end up with negative 2x. You will. Now, what will we need to multiply x by in order to get negative 2x? What did you say? That's exactly right. Oh my goodness, why are you even here? You know everything. You'll need to multiply by negative 2 in order to get negative 2x. Remember, you're always just trying to find out what we need to multiply that first term by in order to get the value down here, that negative 2x in this case. So we need to multiply x times negative 2 in order to get negative 2x. So let's go ahead and multiply this out, right? So negative 2 times x is negative 2x. That's what we wanted, right? And then negative 2 times 1 is negative 2. And then you need to change the signs. Thank you. So this becomes a positive, that becomes a positive, your 2x's cancel out, and you have a remainder of 2 that will be ignored. Because what we were looking for was this right here, the x minus 2. So remember, this is going to be a linear equation here. So your answer is y equals x minus 2. This equation is your slant asymptote. That's it. I'm going to put a box around this. I like putting red boxes around my answers, okay? Just to keep up with them, so they won't run away or escape. And so now we're going to graph this. All right, I have my original function, y equals x squared minus x divided by x plus 1. My oblique asymptote is going to be y equals x minus 2. And we're going to graph this. So my slope is 1. I'll write it as 1 over 1. And my y-intercept is negative 2. I'm always going to begin with the y-intercept. So now I'll be plotting the y-intercept on the y-axis. So I'm at negative 2, about right there. And using the slope, I'm going to go up 1 and over 1. And now I'll have a point right there. So using a dashed line, we'll graph our slant asymptote. So it's going to be a dashed line going right through there. And there you have it. That's the graph of the asymptote. There it is. My rational function will be graphed around there. There you go. Moving on to problem number 3. Alright, in problem number 3 we have f of x equals x squared plus 2 divided by 2x squared minus x. We're going to find the slant asymptote, but we need to verify whether or not we have the correct situation. So remember, we need the highest exponent in the numerator to be one more than the highest exponent in the denominator. Well, in this case, the highest exponent, my highest degree in the numerator, is 2, whereas the highest degree in the denominator, the exponent on the variable, is 2. So that's the same. The highest degree in the numerator is not one more than that of the denominator. It's the exact same. So in this case, you don't have a slant asymptote. You don't have an oblique asymptote. So in order to answer the question, what's the oblique asymptote of this equation? The answer is none. You don't have any. You don't have any oblique asymptotes in this equation because the highest degree in the numerator and the denominator is the same. It needs to be one more than the denominator in order to have an oblique asymptote. Alright, put the red box around it. Not happening. You don't have one for this problem. We're moving on to problem number 4. Alright, so in problem number 4, we have h of x equals x squared divided by x minus 1. The highest degree in the numerator is 2. The highest degree in the denominator? Yeah, it's 1. Yeah, so the difference between the 2 and the 1 is 1, so therefore I can find my oblique asymptote. I can find that slant asymptote now. So I'll be using long division. So my divisor here will be x minus 1 going into x squared. And I'll even show my placeholder here for the x to the first power term. So I'm showing that my divisor is x minus 1, whereas my dividend is x squared, and I went ahead and put a placeholder here, and I called it 0x, because that's how many x's I have, 0. How many times do I need to multiply x in order to get x squared? Oh man, you're so good. I need to multiply by x. So x times x is x squared, right? And then distributing that x times negative 1, it gives me negative x. And then what do you need to do? What did you say? What did you say? I need to change the signs. That's exactly right. I need to change the signs. Thank you. What happens with the x squareds? Oh, they cancel out. You're right. And what's 0x plus 1x? Well, it's just 1x, right? So how many times do I need to multiply x in order to get x? Yeah, I need to multiply by positive 1, because 1 times x is x. So 1 times x is x, and 1 times negative 1 is negative 1, and then we need to do what? Oh, you're so good at this. We need to change the signs. That's exactly right. So my x's cancel out, and I end up with a remainder of 1 that I will promptly ignore. I needed this. That's what I needed, the x plus 1. So my slant asymptote is going to be y equals x plus 1. That's the slant asymptote. Yeah, that's it. I'm red boxing it. Red boxing it. Just like that. And now let's go ahead and graph it. So the slant asymptote is y equals x plus 1. We're going to graph it. Alright. So here's our original function. H of x equals x squared divided by x minus 1. We just found that our oblique asymptote is going to be y equals x plus 1. And we're going to graph it knowing that the slope is 1. And we'll write it as 1 over 1. And the y-intercept is also 1. So we'll begin graphing this on our Cartesian plane by making a point at 1 on the y-axis there. Then using our slope, I'm going up 1 and over 1, so I have a point right there, and I'm going to use a dashed line to graph the slant asymptote. So here I have it, just like so. Alright, there's my slant asymptote, just like that. That was problem number 4. Next up. Alright, here we have problem number 5. We have g of x equals 4 minus x squared divided by x plus 2. Once again, we're concerned about the highest degree in the numerator and the denominator. And notice that my second term in the numerator is negative x squared. That tells me that the degree of that term is 2. So the highest degree in the numerator is 2. What's the highest degree in the denominator? Yeah, It's 1 because this x is to the first power. So once again, we do have a situation where the numerator's highest exponent is 1 more than the highest exponent in the denominator. And it's much easier to figure out when it's already multiplied out and not in its factored form. So the highest degree in the numerator is 2, whereas the highest degree in the denominator is 1. So using long division, you'll end up with x plus 2 going into negative x squared plus 0x plus 4. Remember, you'll want to write your dividend in descending order of your variable, and it's helpful to use placeholders for those missing terms. So I'm going to be multiplying x times negative x in order to get that negative x squared there. Then I'll distribute. You'll end up with negative x times x to give you negative x squared. Negative x times 2 is negative 2x, and then I'll be changing the signs. So this becomes a positive, that becomes a positive, and you'll end up with 2x plus 4. I'll need to multiply x times 2 in order to get that 2x there. So 2 times x is 2x, and 2 times 2 gives me 4, and then I'll need to change the signs. So this terminates, so I don't have a remainder in this problem. So we'll end up with our linear equation at slant asymptote being y equals negative x plus 2. All right, let's go ahead and box it up. All right. And let's go ahead and graph this. So here we have g of x equals 4 minus x squared divided by x plus 2. Your oblique asymptote is going to be y equals negative x plus 2. And then the graph of this is going to call for a slope of -1, and I'll write it as -1/1, and your y-intercept is positive 2. So plotting 2 on our y-axis here, you'll have 2 on the y-axis, and I'll go down 1 and over 1 due to the slope, and let's go ahead and use a dashed line. So here is my dashed line, and that is your slant asymptote. All right. Just like that, ladies and gentlemen, that's problem number 5. For problem number 6, we have f of x equals 4x cubed plus 3x squared minus x divided by 2x squared minus x minus 1. Once again, I'm focusing on the degrees of the numerator and the denominator. The highest degree in the numerator is 3, whereas the highest degree in the denominator is 2. The numerator is 1 more than the highest degree in the denominator, therefore, we will have an oblique asymptote. So we'll use long division for this. So my divisor is going to be 2x squared minus x minus 1 going into 4x cubed plus 3x squared minus x. I'll need to multiply 2x squared times 2x in order to get that 4x cubed. So next I'll be distributing. So 2x times 2x squared is 4x cubed. 2x times negative x gives me negative 2x squared. And then 2x times -1 is negative 2x. From here, I'll be changing the signs. So this is a negative, a positive, and a positive. My 4x cubes now will cancel out. I'll add the 3x squared plus the 2x squared to give me 5x squared. Negative x plus 2x is a positive x. And I can go ahead and add a 0 here. All right, and bring that down. And what do I need to multiply 2x squared by in order to get 5x squared? Absolutely. I'll need to multiply by 5 halves. I need to multiply by 5 halves. So this is going to be plus 5 halves here. So distributing this, 5 halves times 2x squared is going to give me a positive 5x squared. Multiplying 5 halves times negative x gives me negative 5 halves x, and then multiplying 5 halves times -1, I have negative 5 halves. The next thing I want to do, change the signs. So the 5x squared becomes negative, the negative 5 halves x becomes positive, and the negative 5 halves becomes positive. All right. From here, the 5x squareds will cancel out. Adding x plus 5 halves x gives me 7 halves x. Plus 0 plus 5 halves is 5 halves. All right. In order to get that 7 halves x, I made that 1x into 2 over 2x. So I changed the coefficient of 1 into 2 over 2, added that to 5 halves, that gave me that 7 halves there. All right. There you have it. So now that I have this, since the highest degree in the divisor is higher than that of what I'm trying to go into, this is considered my remainder. Okay. Okay, so the linear equation that I'm looking at, this 2x plus 5 halves, this is going to be my slant asymptote. So we'll write it as y equals 2x plus 5 halves. All right, and this is the slant asymptote. Red boxing it. Okay, let's go ahead and graph this. So once again, we have our original function for problem number 6. It's f of x equals 4x cubed plus 3x squared minus x divided by 2x squared minus x minus 1. And my oblique asymptote, that slant asymptote, is y equals 2x plus 5 halves. All right, so my slope is going to be 2, and I'll write that over 1. And my y-intercept is going to be 5 halves, and I may even just write it as 2.5. All right, because it'll be easier to plot. So knowing that I'm going to start at 2.5 on the y-axis, I'm going to put a point right here, okay, at 2.5, and then using my slope, I'm going to go up to 1, 2, and then over 1, and I have a point right there. Using a dashed line to graph my asymptote, I have a dashed line going right down here, right down that line, arrows on both ends, and this is the graph of my asymptote. Done and done. That's right. That's the graph of problem number 6. On to our next problem. In problem number 7, we have g of x equals x to the 4th power minus 81 divided by x squared minus 1. Our oblique asymptote in this problem doesn't exist. It's none. Let's talk about why it's none. The reason why we don't have an oblique asymptote in this problem is because our highest degree in the numerator is 2 more than that of the denominator. Remember, the difference between the degrees in the numerator and the denominator needs to be 1. So because my highest degree in the numerator is 4 and the highest degree in the denominator is 2, that difference is too much. The difference has to be 1 in order to have an oblique asymptote, aka a slant asymptote. All right, so we don't have an oblique asymptote, a slant asymptote for problem number 7. That result is none. Just none. Got a box around it. And now for our final problem. In problem 8, we have f of x equals x squared plus 3x minus 4 divided by x minus 5. The highest degree in the numerator is 2, whereas the highest degree in the denominator is 1. Therefore, we do have a difference of 1 between the highest degree in the numerator and the highest degree in the denominator. So I'll be using long division in order to solve this. My divisor is going to be x minus 5 going into x squared plus 3x minus 4. I need to multiply x times x in order to get x squared. X times x is x squared, and then x times negative 5 gives me negative 5x. Changing the signs on this here, the x squared becomes negative, 5x becomes positive. My x squareds will cancel out. I'll combine 3x and 5x to get 8x minus 4. We need to multiply x times 8 in order to get 8x. So multiplying that out, 8 times x is 8x, and 8 times negative 5 gives me negative 40. Then I need to change the signs. All right, my 8x's cancel out. I'll be bringing down a positive 36 as my remainder, which will be ignored. I need this, the x plus 8. That means that my slant asymptote is going to be y equals x plus 8, ladies and gentlemen. And I hate that equal sign too. I'm going to fix it. That's right. I'm gonna fix it because it's ugly. Oh, that's worse. Is that worse? You're killing me. There, that's much better. Okay, this is my slant asymptote, ladies and gentlemen, and I'm gonna put a box around it, and you can't stop me. There you go. Y equals x plus 8. Let's go ahead and graph that. We have our original function, f of x equals x squared plus 3x minus 4 divided by x minus 5. We just found that the slant asymptote is y equals x plus 8. All right, so that means that my slope here is going to be 1. I'll write it as 1 over 1. And my y-intercept is going to be 8. Okay, so graphing this, I put a point at 8 on the y-axis. So I have a point right there. I'm going to go up 1 and then over 1. To get another point here. That specific point, by the way, is going to be 1, 9, if you wanted the order pair. And then I'm going to use a dashed line. So I have a dashed line going right through there, and this is my oblique asymptote, ladies and gentlemen. Done and done. Well, ladies and gentlemen, I hope you enjoyed this video over oblique asymptotes, aka slant asymptotes. And once again, please rate, comment, and subscribe. And if you're able, please donate, as that helps us bring you more free math tutorials from me, Mr. Witt, and Fort Bend Tutoring Peace.
Oh Lord, there's so many kind of fractions. They got proper, improper, addings, subtracting, multiplying, dividing, mixed numbers, LCD. Ooh, that's like my TV. Simplifying, and my favorite of all, your least common denominator.